today's class. So for the new student, I'm John Mark. I'll be taking you through QA. And for today, we'll be covering calculus and function. Calculus and function. That's another topic that will be examined. So I've decided that this strategy that first of all, I'll start with the topics that I know that must be tested in each and exam. So that's what I'll do. So kindly bear with me. For those KCE students, I know there are some topics I have not completed with you from the syllabus, but in this case, I need to cater for everyone so that everyone can pass. So now let's go to our main objective there. So today we are doing our calculus and function. Now calculus and function, what's the difference between the calculus and function? Now calculus is just a branch of mathematics of which it is classified into two, differentiation and integration. Then calculus will be applied in relation to functions. Therefore, a function is just a mathematical expression of the relationship existing between variables. So, and then for function, we have the major three types of function, the classification of functions. Number one, we have what we call a univariate function. Now, univariate function is a function with only one independent variable. Then we have bivariate function. Now, for the bivariate function, it's a function with only two independent variables. And then number three, we have what we call multivariate variable. Multivariate function. Now, for the multivariate function is a function with at least two independent variables. So those are the major classification of function. We have the univariate, bivariate, and multivariate. Then we have other types of functions. One being the linear function. We have quadratic function, logarithmic function, exponential function, etc. Then we have said that on a function and calculus be looking mostly with differentiation and integration. So let's go to the whiteboard. I show you what I mean. So it's calculus and function. We have said that calculus is just a branch of mathematics which is classified into two. We have differentiation and we have integration. And kindly, you need to get this clearly. I've said that calculus and function will be tested, so don't ignore it. Don't ignore it. So then we have said that calculus will be applied in relation to function. And we say that under function, we have various classification of function. Those are the classification. One, we have said that we have what we call a univariate function. Now, univariate function, and then number two, we have what we call a bivariate function. And number three, we have what we call a multivariate function. What's the difference? Univariate function is a function with only one independent variable. E.g., if I give you an idea, say like a plus bx. So in this case, our independent variable is only one, that's our x. For bivariate has two independent variables, e.g., y is equals to a plus b1x1 plus b2x2. So in this case, we have x1, we have x2. So we have two independent variables. Then for multivariate function, it's a function with more, at least two. So in this case, we'll be present that y is equals to a plus b1x1, b2x2 plus blah, 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 bnxn. Now that's what we call a multivariate function. Then we have said that we have other types of functions. Tukasema number one, we have logarithmic function. Now, logarithmic function is a function with a log value or a log element. Number two, we have what we call the exponential function. Also, we have what we call polynomial function. Also, we have what we call quadratic function. Now, for quadratic function, remember, how do we get for quadratic function? Our x is denoted by minus b plus or minus square root of b square minus 4ac over 2a. So kindly get this to be widely applied under this topic. So those are the major classification of functions, and those are the types of functions. And then you may be asked, what are the functions? What are the functions? Now, functions are just a branch of mathematics which is classified into two. We have differentiation and integration. Now, for differentiation, it's a function with only one independent variable. E.g., if I give you an idea, say like a plus b1x1, b2x2 plus blah, 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 bnxn. Now that's what we call the application of function in business, the application of function in business. So a function has many applications in business. Number one, they can be used in CVP analysis when doing the CVP analysis. Then number two, in determining the depreciation or appreciation, also can be used in price setting. Price setting also can also be used in computation of wages and salaries. Another application, also they're used also in linear programming, the topic we did there. Also they're used in demand and supply analysis. Yeah, those are the sums of the application of calculus and function in business. CVP analysis, determining the depreciation or appreciation, price setting, determination of wages and salaries, linear programming, demand and supply. So to start with, I need to start with, you can screenshot that before I erase it. I want now to start with the differentiation. So let's start with the differentiation. Differentiation. Remember I said that the calculus and function is classified into two. We have differentiation and we have integration. Now, differentiation is just a determination of the rate of change or the slope or the gradient, where the two variables are connected to each other using an unlinear function, which is usually denoted. This is how we denote the differentiation. You differentiate y, that's the dependent variable, in respect of x. That's how we denote it. That's what we show the derivative or the differential function. You're differentiating y in respect of x. So y will be our dependent variable. Then x will be our independent variable. Then how do we show this? I don't want to give you the steps. I want you to understand. How do we differentiate? Now, for example, if you're given a function like this, you are told that differentiate the following function. You differentiate the following function. Like you are given like 6x raised to power 5 plus 3x raised to power 4. Then you're given x 9x cubed. Then you are given 4x squared. Then you are given 10x plus 500. Now, assuming you are given a function like that, that y is equals to that. So in that case, how do you differentiate? I want you to get the concept of differentiation. You say you differentiate y in respect of x is equals to, so note this is what you do. You take 5 times 6, you get 30. So it will be 30x, here 5 una minus 1. So 5 minus 1, you will get 4. Plus 4 times 3, you get 12. So it will be 12x, here 4 una minus 1. It will be x raised to power 3. Plus 3 times 9, you get 27x una minus 1 squared. Plus 2 times 4, you get 8x. Okay, minus 1 inabakia only 1. Plus, this is the same as 10 raised to power 1. So it's 1 times 10, you get 10. Then your 1 una minus 1. So x raised to power 0 inaisha. So inakuwa hivyo. And then you don't show this one. You see, you are differentiating in respect of x. Here you don't have x. It can be noted using a c. Now, c is what we call a constant figure. Good. So that's how we differentiate. So now let me show you another illustration. I want you to differentiate this. Differentiate this. Y is equals to 10x raised to power 3 plus 30x squared plus 4x plus 1000. So, tuende kazi. So it will be, you differentiate y in respect of x. Then, Charles nimesema ufanye, wacha kuniangalia. Also given, compute. You can see Paris is computing. Kindly don't hide your identity. I need to see you so that I can see what you are doing. So it will be 10 times 3 times 10. You get 30x, you minus 1 square, plus 30 times 2, you get 60x x, hii una minus 1, sinakuwa x raised power 1, plus this is the same as x raised power 1. 1 times 4, you get 4. 1 minus 1 inaisha. Good. So now let's continue. That's all about differentiation. Then under differentiation, we have what we call the high order differential. High order differential. Now, the high order differential is usually used to compute that when you are getting what we call the turning point. They are called the high order differential. High order differential, the HODs. Now, the HOD are used to determine the number of times a function can be differentiated. Or, you see, the number of the times a function can be differentiated is known as the turning point. So you're saying that it's used to show the number of times the function has been differentiated. Then you have said that HOD are also used to determine the turning point. At a turning point, the gradient is equals to 0. So we are saying that at turning point, if you differentiate y in respect of x, you should get a gradient of 0. So now let me give you an illustration. If I say that, can you determine the turning point of the following function? Determine the turning point of the following function, or you obtain the HODs. So you're given a function like y is equals to x raised to power 4 plus x raised to power 3 plus x squared plus x plus, let's say 30. So solution, we want to get the turning point, or we want to get the HOD. So the first one will be, you differentiate y in respect of x. So itakuwa 4 times 1, so it will be 4x una minus 1, inakuwa raised to power 3, plus 3 times 1, so it will be 3x square, plus this is the same as 2 times 1, so it will be 2x una minus 1, inabakia just x, plus this is x raised to power 1, so it's 1 times 1, you get 1, then you minus 1, x inaisha. So now that's what we call the first order differential. First order differential. Now, twende ya pili, it will be d2y over dx squared. That's the second differential. So itakuwa 3 times 4, you get 12x raised to power 2, because unatoa moja, plus 2 times 3, you get 6x, una minus 1 inabakia x, plus the same as x raised to power 1. So it's 1 times 2, you get 2. X, see x raised to power 1 minus 1, inaisha. Actually, this one should be just 2. Now that's what we call the second order differential. Then, twende ingine, the third one is d3y over dx cubed. We are doing the third differentiation. So it will be 2 times 12, you get 24x, unatoa moja ni x, plus this is 6x raised to power 1. So itakuwa 1 times 6, so itakuwa 6, then una minus 1, inakuwa 0. So hiyo inaisha. So ikiisha hivyo, now that's what we call the third order differential. Tuende wengine is d4y over dx4. So it will be the same as raised to power 1. 1 times 24, you will get 24, na hiyo inaisha hivyo. There is no other x. Now that's what we call the fourth order differential. Now in this case, our turning point is 24. So what I mean our gradient is 24. Hatujafikia the turning point. The turning point should be 0. So that means you perform another one, d5y dx5. So that if you differentiate 24 in respect of x, it will be automatically 0. So that's what we call the fifth order differential. Good. So that's all about the turning point. I don't have to cram that. No one will test you that. So that's the concept of differentiation. In case you have a question, kindly ask there. And for those who are having issues with the video, that's all about network connectivity. So now let's go to the second part. That was differentiation. Now let's look at integration. Now, integration means when you say we are integrating, it's all about sum up or combining. And integration is opposite of differentiation. So now we are looking at integration. Tumesema differentiation, you are differentiating, taking apart. Integration, you are bringing together. So that means integration means the sum up. And the integration will be the opposite. Integration is the opposite or the vice versa of differentiation. So, and this is how the integration is denoted. This is the sign for integral. We are integrating y in respect of x. That's how we show that. So let me take you direct to the point. I don't want to show how to come up with that formula. I want you to integrate this. I want you to integrate this. Assuming you are given equation y is equals to 24x cubed plus 9x squared plus 18x plus 2. And you are told to integrate that. How do we integrate that? So this is a solution. You say you integrate y in respect of x. So itakuwa hivi. So this is 3. You add 1. Kumbuka kwa differentiation you are deducting 1. So it's 3 plus 1, you get 4. Then you divide by 4. So it will be 24 divided by 4, which is 6x raised to power 4 because it's 3 plus 1. Kama huku shika hiyo, shika hii plus. Tuko hapa sasa. This is raised to power 2. You add 1, so it is 2 plus 1, which is 3. Then you divide by 3. So it's 9 divided by 3, you get 3x cubed because it's 2 plus 1. Plus, this is the same as x raised to power 1. So you add 1. So 1 plus 1, you get 2. Then you divide by 2. So it will be 9x squared. Plus, now this 2, kindly let's be here. This 2 is the same as 2x raised to power 0. But we are not showing because it's a 0. This 0, you add 1. So 0 plus 1, you get 1. Then you divide by 1. So that means it will be 2x raised to power 1. And then you can add c. Now c will represent the constant. Good. Now someone is asking, what if you perform the fifth tuko kwa high order differential? The fifth one bado c 0. You just continue. It can even go for high order differential. Can even go up to 10. So that one has no limit. I hope you are answered. Good. That's all about integration. I've shown you how to differentiate, how to integrate. Another concept you need to determine is that integration and differentiation, both the differentiation and the integration is widely applied in areas of profit maximization. Maximization. Yeah. Irudie tena. I've said that differentiation and integration is widely applied in areas of profit maximization. And we say that at profit maximization, you need to note this, at profit maximization, marginal revenue is equals to marginal cost. The marginal revenue is equals to marginal cost. What does that mean? If the marginal cost is equals to marginal revenue is equals to marginal cost, therefore, the profit denoted by pi is equals to 0. Because if the marginal revenue and the marginal cost, they are the same, that means the profit is equals to 0. And how do we get the profit? Profit is total revenue minus total cost. How do we get total revenue? Total revenue is the price times quantity. So I want you to make this at your fingertips, that at profit maximization, marginal revenue is equals to marginal cost. Hence, therefore, the profit is equals to 0. And how do we get the profit? Profit is equals to total revenue minus total cost. And to get the total revenue, you just take the price, you multiply by the quantity. Good. Now with that, we can start doing computation now. Let's go to the serious business. Take out your past paper. We start with May 2016 question 1C. May 2016 question 1C. Yeah, May 2016, question 1C. We are doing part C of the question. Shujaa remitted this in the manufacture of product named Z. The product Z is produced on order, and the company does not keep inventory of the product. The demand and the total cost function in thousands of shillings of the company are given as follows. So you have the price function there, and TC there, that's the total cost, where P is the unit selling price, Q is the quantity demanded in units, and TC is the total cost required. The maximum profit of the company. The moment you see at the maximum, you see that required, they say the maximum profit of the company. So you say that. So we are doing May 2016. Question 1C. So we have said that at profit maximization, marginal revenue is equals to marginal cost. Therefore, profit is equals to 0. And how do we get profit? Profit, I say that, is total revenue minus total cost. And how do we get the total revenue? Is the price times quantity. So tuanze hapo. Let's get the total revenue. In this question, you're already given the price there. So to get the total revenue, we said there's a price, and you're told that the price is 190 minus Q is the price times the quantity you multiply by Q. So that means your total revenue will be 190 times Q, you get 190Q minus Q squared. That's the total revenue. Then we already have the total cost. You're already given the total cost. So now what we're remaining with, now we can get our profit. And how do we get profit? We have said that to get the profit is take total revenue minus total cost. So tuangalie hapa. So you take the total revenue, tumepata it's 190Q minus Q squared minus the total cost function. Here's the total cost function. So we have Q squared plus 10Q plus 500 and should equals to 0. Remember, you said that the profit is equals to 0. Therefore, let's open the bracket. Let's open the bracket. If you open the bracket, it will be 190Q minus Q squared minus Q squared. I hope you are there. Now, when you're opening the bracket, you change the sign. Kama itakuwa minus 10Q, hata itakuwa minus 500 is equals to 0. When you open the bracket, you change the sign. Now, let's bring the right term together. We have 190Q minus 10Q. So you get 180Q. Then we have minus Q squared minus Q squared. That means it will be minus 2Q squared. That will be minus 2Q squared. Minus 500 is equals to 0. Now, that's what we call the profit function. But the question amesema the maximum profit. After you come up with the profit function, to get at maximum, you differentiate. You differentiate profit in respect of quantity. So kama hii itakuwa, it's 1 times 180, you get 180, Q inaenda, minus 2 times 2, you get 4Q is equals to 0. So pereka ile the other side. So itakuwa 180, e negative 4 pereka the other side. So it will be 4Q, which is a positive. So to get Q, you divide both sides by 4. So to get that, the quantity to maximize the profit will be 180 divided by 4. Napata ngapi? It will be 45. It will be 45. But the question wanted what? The maximum profit of the company, the maximum profit. Now, we already have the quantity. This is what we call the quantity to maximize profit. Now, to get the maximum profit, ukuje hapa, you already have the profit function. So just substitute. So it would be 180, this one, times Q, which is 45, minus 2Q squared. Our Q is 45 squared minus in 500. Yeah. So ukifanya hivyo utapata 3550. Good. Let's go to note number 2. The requirement number 2. Number 2, walikuwa nataka the output level that would maximize total revenue. Output level to maximize total revenue. So in this case, tumetoka ku maximize profit, you're maximizing total revenue. So we already have the total revenue function. Here is the total revenue. The total revenue tuliona it was 190Q minus Q squared. If you want to maximize it, you differentiate. So this is what you do. You differentiate total revenue in respect of quantity. So itakuwa in the same as raised power 1. 1 times that one itakuja 190 minus itakuwa 2Q and it should equal to 0. Peleka hiyo the other side. So it will be 190 is equals to, the other side will be positive 2Q. That means our quantity will be 95. Now this is what we call the quantity to maximize total revenue. Here we had gotten 45. This is the quantity to maximize profit. So now this is what the examiner wanted, the quantity to maximize the total revenue. And in case the examiner, that one is not part of the question. In case the examiner asks you about the total revenue, to get the total revenue, you just take, you already have the total revenue function here. You just take 190 times Q, our Q is 95, minus Q squared, which is 95 squared, and you get that. Good. Tuende kazi. Let's try another question. We try another question. May 2018, question 1B. May 2018, question 1B. So I'll share the note of the session. So it's not a must you have to copy. So kindly don't worry, I'll share the notes. So number B, you are told that the unit price and the total cost function associated with the production and sales of a certain electric component are given by the following equation. So we have the price there and we have TC, that's the total quantity, where P is the unit price of the electric component, Q is the number of electric component produced and sold. TC is the total cost required. The number of electric component that would maximize profit. That means they want Q. Number 2, the maximum profit. And number 3, the maximum total revenue. So, tumesema. So we are doing May 2018. Question 1B. Number 1, they want the number of electric component that would maximize profit. Tumesema at profit maximization, marginal revenue is equals to marginal cost. Hence, profit is equals to 0. And how do we get profit? Is the total revenue minus total cost. And how do we get the total revenue? Is the price times quantity. So now let's start getting by getting the total revenue. So in this case, we already given the price. So you'll take price, which is 100 minus 5Q, then you multiply by Q. So that means our total revenue will be 100Q minus 5Q squared. So now let's get the profit, which is total revenue minus total cost. So you'll take 100Q minus 5Q squared minus the total cost. Now I want you to note this. I just want to use the shortcut here. The total cost, I want to minus it directly. If I deduct it directly, I open the bracket directly. Itakuwa minus Q squared minus 4Q minus 300. If you open the bracket directly, and that's what I want to do. So tumesema if you open the bracket, the sign changes. So it will be minus Q squared minus 4Q minus 300. When you open the bracket, is equals to 0. Now from there, we bring the right terms together. So 100Q minus 4Q, you get 96Q. Minus 5Q squared minus Q squared, you get minus 6Q squared. And then minus 300 is equals to 0. Now that's the profit function. But wamesema maximum. Ukisikia maximum, you have to differentiate. So differentiate profit in respect of quantity. So itakuwa ngapi? So that one will be 96 minus 2 times 6, you get 12Q is equals to 0. Peleka hii the other side. So to get Q, itakuwa 96 is equals to 12Q. You divide both sides by 12. So na utapata your Q. Your Q inakuja ngapi? It will be 8. Yeah, your Q is 8. And that's what the examiner wanted, number 1. The number of electric component that would maximize profit. We are through with that. Number 2, they want the maximum profit. The maximum profit. So number 2, to get the maximum profit, you already have the profit function here. So you just substitute. You already have the quantity to maximize the profit. So what you do, like utachukua 96, you multiply by the quantity, which is 8, you deduct 6Q squared, so it will be 6. Our Q in this case 8 squared minus 300. So, and that one you get 84,000. Let's go to number 3. Number 3 is the maximum total revenue. Maximum total revenue. So we already have the total revenue function. This was the total revenue function here, which was 100Q minus 5Q squared. But they have said maximum. If they say maximum, you have to differentiate. So you differentiate total revenue in respect of quantity. So it will be the same as raised by 1. So it's 1 times 100, you get 100 minus 2 times 5, you get 10Q is equals to 0. That means Q will be 100 divided by 10, because ukipeleka the other side will be positive. So it'll be 100 divided by 10. So it'll get 10. Now this is what we call quantity to maximize total revenue. Hii tulikuwa tumepata 8 is the quantity to maximize profit, is to maximize the quantity, to maximize the revenue. So to get the total revenue, you already have the total revenue function here. So itakuwa 100Q, our Q ni 10, minus 5Q squared, 10 squared. Hiyo ni 1000 minus 500. Na unapata 500. Good. Let's still try another question. I want us to do like 5 questions. We do another question. May 2017, question 1C. May 2017, question 1C. And kindly be trying my assignments. So for the topic we have started with, I know some students are wondering why. We have some KCE student, we are remaining within with the transported assignment. That one I'll do it later. So first of all, I have to make you pass the exam. That's why I've started with these selected questions. So kindly be attempting my assignments. I urge you. So you'll be sending to me via my WhatsApp number. I'll share my number later. Yeah, May 2017, question 1. Yeah, question 1C. So you are told that the average revenue and the total function of a certain company are given by, so you have the average revenue and we have the MC, marginal cost. Now, when you are given the marginal cost, that means it was total cost ikakuwa differentiated. So in this case, we're given the marginal cost, not the total cost. So that means these marginal costs have already been differentiated, where AR is the average revenue, MC is the marginal cost, X is the level of output required, the profit function. So in this case, they have not, hakuna mali wamesema maximize. So if they say just the profit function, say the profit function, they just need that. And how do we get that? It's just total revenue minus total cost. They have not said maximum. So how do we get the total revenue? Now, the total revenue, we said it's price times quantity, but in this case, it's totally different because you're already given the average revenue. If you're given the average revenue and you want to get the total revenue, to get the total revenue, you just take the average revenue, you multiply by the quantity or X. Now, this is what I mean. If you're told that, let me give you just an illustration. If you're told that the total marks of 5 students, assuming they did a cut, and you're told that the total marks, it's, let's say 50, and there were 5 students, so can you be able to get the average? Now, to get the average marks, this was the total marks, which is 50 for 5 students. To get the average marks, you just take 50 divided by 5, of which utapata 10. So you already have the average, and you umepewa hapa. So that means if you are told that, now you are given this statement, that the average marks of 5 students is 10. That's the average. So can we get the total marks? Yes, you just take the average, which is 10. Then you multiply by the number of students, 5, for you to get the total. In this case, we are given the average revenue. So to get the total revenue, you take the average, you multiply by the number of units sold for you to get the total. So to get the total, you already given the average, and the average you are given, it was 50 minus 15x. That's why I decided to use X here. Kama ingekuwa Q, I just used Q. So it's the average cost, average revenue, you multiply by X. So that means our total revenue will be 650x minus 15x squared. That's the total revenue. To get the profit, because they want the profit function, you take the total revenue minus total cost. You already have the total revenue. So what we need is the total cost. How do we get the total cost? Now, in this case, you are not given the total cost, you are given the marginal cost. That means the marginal cost has already been differentiated. So to get the total cost, you have to integrate the marginal cost for you to get the total cost. So to get the total cost, you integrate. To get the total cost, you integrate the marginal cost in respect of X. The marginal cost ulikuwa umepewa, it was 9x squared minus 14x plus 180. That was the marginal cost. So now let's get the total cost. We're integrating this, the marginal cost, so that we can get the total cost. So tukasema tunaongeza moja hapo juu. So it's 2 plus 1, you get 3, then you divide by 3. So 9 divided by 3, you get 3x cubed minus, this is the same as 14x raised by 1, you add 1. So it will be 1 plus 1, you get 2, so you divide by 2. 14 divided by 2, you get 7x squared plus, this is the same as x raised power 0. So you add 1. 0 plus 1 is 1, you divide by 1. Kwa hivyo itakuwa 180 raised power x, because now it's 0 plus 1, which is 1. So that's the total cost. Then you can add, remember tulisema that you add C. Now you say that C is the constant of the fixed cost. In this case, you're already given, we are told that the fixed cost of production is 25 million. That's the fixed. So now to get the total, you have to now to factor in. Now that KCE, later the fixed cost, which is 25. So now let's get our profit. Now our profit, you just take the total revenue, which is 650x minus 15x squared minus, we are minusing the total cost. So allow me to open the bracket directly. So if you are minusing the total cost, you just change the sign. Like this one will be 3x cubed, inakuwa plus 7x squared, inakuwa minus 180x, inakuwa minus 25 is equals to 0. And then turahisha hiyo kazi, we bring the right term together. So allow me to start with the cubed. So kama itakuwa minus 3x cubed, tuende kwa square. it's minus 15x squared plus 7x squared. So that one will get minus 8x squared. Then we have 650x minus 180x. Itakupea ngapi? What are you getting? Yeah, 650 minus 180, is that for what? Yeah, 470, yeah? So it would be positive, eh? 470x and then plus 25. So yeah, that's number one, the requirement number one. Eh? The examiner wanted the profit function. Let's go to number two. The level of output that would maximize profit. Level of output to maximize profit. Ukisikia maximize, eh? So in that case, now you factor in the differentiation. So you differentiate profit in respect of x. Kama itakuwa minus 3 times 3, you get 9x squared, minus 2 times 8, you get 16, x, una minus 1 inabakia x, plus the same as raised by 1. 1 times 470, you get 470. Hiyo imeisha hivyo. So, hii si kama ile ingine. The other one ulikuwa unapeleka the other side and then you substitute. Eh? So, in this case, to get x, now you have formed what you call a quadratic function. Kama hii ndio a, this is b, this is c. So, this is how the quadratic function looks like. Eh? Inakuanga y is equals to ax squared plus bx plus c. So, e squared inakuwa imepresent a na ndio hii. So, our a will be negative 9, eh? bx, 16x. So, our b will be 16, and then c, it's 470. So, and we said to get that, use the quadratic function, x is equals to minus b plus or minus square root of b squared minus 4ac, you divide by 2a. Now, let's do that. So, minus b. So, our b is minus 16. Ukiongezea minus ingine, it turns to positive. Eh? So, it will be 16 plus or minus, you get the square root. B squared, our b is negative 16. Eh? If you square any negative, it becomes a positive. So, it will be 16 squared minus 4ac. So, it's 4a. Our a is negative 9. C, our c is 470. You divide by 2a. Our a is negative 9. Now, this one you can compute and get a wrong answer. Why? I know you assume you know how to use a calculator, but you don't know how to use a calculator. Always apply board mass. Eh? Like in this case, just take 4 times negative 9 times 470 equals. Then you press 16 squared minus answer equals. Then you get square root of the answer equals. Then plus or minus. Eh? Now, if you use plus or minus, you'll get two answers. One will be negative, the other one will be positive. Eh? Now, for this one, remember you are getting quantity. You cannot produce a negative quantity. Eh? So if you get a negative answer, you ignore. You take the positive one. Eh? Because in this case, we are dealing with the quantity. So we take the positive one. So if you compute that one, like a good student, you should get 6 units. The other one will be negative. Eh? You ignore the negative. Good. Any question there? Yeah, this approximate. You can get either 6.7, 6.8, ile tu utapata, eh? Yeah. Good. So andika assignment hapo. Assignment. Assignment. I want you to try this question. This question never misses, eh? May 2019 question 1A. May 2019 question 1A. Question 1A. Good. So now let's try another question. December 2012, question 1A. Inataka mfanye December 2012, question 1A. Kwa wenye hawana, I want to display it here. I'm just giving you 3 minutes. Eh? Yeah, it's December 2012 question 1A. Yeah, there is the question. So tuende kazi. I'm sure some of you hakuna kitu wanaona hapo. So Medicine Limited is a pharmaceutical company that manufactures two types of coughing serum, Lara and Sarama. The total cost and the total revenue of producing the coughing serum are given by, so you already have the total cost, you have the total revenue. Where T is the total cost function, TL is the total revenue function, S is the number of carton of Sarama, L, L, not R, is the number of carton of Lara. So required, the maximum profit of Medicine Limited, the maximum profit. So that's December 2012, question 1A. They want the maximum profit. We say that at profit maximization, marginal revenue is equals to marginal cost. Hence, profit is equals to 0. And how do we get profit? We have said that profit is total revenue minus total cost. Why is why already we are given the total revenue, we are given the total cost. So that means the profit will be, you take the total revenue, which is negative 38,400 S minus 36 L squared plus 438 S squared plus the 2 million minus, so you see the total cost. I want to open the bracket directly, so I change the sign. So like it will be minus 1 million plus 486 S squared plus 324 SL plus, I'm changing the sign, 27L squared, and it is equals to 0. We bring the right term together. S and a partner, so that means will be mean as 38,400 S. Then we have minus that 6L squared plus 27L squared. So that is 27 minus 36. So that one you will get what? So that one will get minus 9L squared. 438S squared plus 486S squared. That's a positive 924S squared. And then we have 324SL plus 324SL plus 2 million minus 1 million. You get 1 million is equals to 0. Now that's the profit function. But they want the maximum. At maximum, we have to differentiate. How do you differentiate? In this case, we have S, we have L. So you differentiate profit in respect of S. Also, you differentiate profit in respect of L. So to answer S. So this is same as raised power 1. That one times that one will be minus 38,400. We don't have S, we have S here. Plus, it's 2 times 9, 24. So if you multiply that one, you get 1848 S plus, we have another S here. So this is same as S raised by 1. So it's 1 times 324, you get 324 minus 1. S inaisha unabakia na L is equals to 0. You can correct equation number 1. Now let's differentiate in respect of L. So in this case, we have L, so itakuwa minus 2 times 9, you get 18 L plus, we have another L here. So it's 324 SL. We are defining in respect of L. Kwa hivyo L, it's 1 times 324, you get 324. L inaisha unabakia na S is equals to 0. You can call it equation number 2. Now using equation 1 and 2. Like the first equation itakuwa 1848S plus 324L is equals, hii wacha nipeleke the other side, so equal positive 38,400. Then equation 2, wacha nianze na S, so it will be 324S minus 18L is equals to 0. You can multiply by 1, you multiply by 18. Remember 18 squared, you just get 324. So itabakia 1848S plus 324L is equals to 38,400. Then 18 times 324. So hiyo utapata ngapi? That one is 58, that 2S minus 18 times 18, you get 324L. 18 times 0, you get 0. So do we add or do we minus? So we add. If you minus 324, minus becomes a positive, so you add. So that 8,400 is equals to 1848 plus 58, that 2, you get that 680 S. So that means S, you can get S there. So it will be 38,400 you divide by 3680. Na utapata S ni 5. If you get S is 5, you can use any of the equation, either equation 1 or equation 2. For example, like if I use this equation 2, we already have S ni 5. Kwa hivyo itakuwa 324 S is equals to, hii unaipeleka the other side, inakuwa positive 18L. Kwa hivyo L you get 90. I think by that you are good. Yeah, I can see someone is lost. Find a way. So let's try another question. I want to equip you adequately for this topic, because it will be there, it must be tested. So let's try another question. We can do May 2015 question 1, B and C. May 2015 question 1. We do part B and part C. Let's start with question B or part B. Highlight for application of function in business. Yeah, post your answer there. Right there. So Vita, I can see your question. Eh? So the question was not okay. The question we had done previously. This question, this one. They wanted the maximum profit of Medicinal Limited. Tumepata L na tumepata S. So that was not the end. You just substitute them to the profit function. So I have ignored that because already you already have the concept. It's just substituting. Good. You are posting your answers there. So yeah, that's good. But in case an examiner asks the application, usiandike venye munaandika hapo, wages and salaries, demand and supply. Just write in determining, like you see, like price setting, that one is correct. That one is complete. But you say demand and supply, you say in computing demand and supply, computation of wages and salary, CVP analysis. I can see Joy ameandika zote hapo. CVP analysis, price setting, depreciation. Huyo student alikuwa anasikiza. Good. So now let's do that. The other question. That was part B. Let's go to part C. ATC Limited manufactures an electric component whose marginal cost function is estimated to be quadratic in nature. So mushike hiyo, whose marginal cost function is estimated to be quadratic in nature. So what does that mean? That means that the marginal cost, ni quadratic, tumesema quadratic, it's AQ squared plus BQ plus C, or the same na kusema AX squared plus BX plus C. That's the marginal cost. That's what you are given there. That ABC Limited manufactures an electric component whose marginal cost function is estimated to be quadratic in nature. The table below shows the marginal cost incurred by the company at different production levels. So you have the production level in units, we have the marginal cost. The unit price associated with the selling Q units of the component is given by, so now when you're writing this function, you see like I have indicated two here. You see the first one, the second one. You can write X or you can write Q. Now that one will be guided by what you are given here. Like in this case, you see, like in our price function, we are given Q. So I'll use the second one, the Q instead of X. So the unit price associated with the selling Q units of the component is given by, so you have the price there is a function required, the marginal cost function, the marginal cost function. So how do we get the marginal cost function? So inataka tufuatane tafadhali. So now this is what you do. If you ask about the marginal cost function, we are told that the marginal cost takes the quadratic format or takes the quadratic form. In this case, from the question, we already given the marginal cost. We have the marginal cost, we have the production level. Now the production level, the units, that will be a Q. Now, like the first one, you can do this. This is the first equation we are developing here. We already have the marginal cost, which is 22. Kwa hivyo itakuwa 22 is equals to AQ squared. AQ squared. Our Q is 50, that's quantity. Kwa hivyo Q squared. Kwa hivyo you do 50 squared. If you square 50, utapata ngapi? You'll get 2500A plus BQ. Our Q is 50. Kwa hivyo itakuwa 50B plus C. Call it equation 1. Kama huku shika hiyo, shika the second one. The second equation. Marginal cost is 100. So itakuwa 100 is equals to this marginal cost. AQ squared. Our Q of the production level is 100. So 100 squared, you'll get 10,000 A plus BQ. So our Q is 100. Kwa hivyo itakuwa 100B plus C. You call it equation number 2. Tuende ya tatu. The unit is 200, but the marginal cost is 436. So our marginal cost here will be 436 is equals to, twende hapa, AQ squared. Our Q is 200. So Q squared is 100, Q squared, 200 squared, you get 40,000 A plus BQ. Our B, our Q is 200, so it would be 200B plus C. That's equation number 3. Hope to kosa mpaka that point. Now from there, now let's using equation 1 and 2 to eliminate C. To me, the first one and the second one. I want to do it directly. I can do this. Well, I'm using 1 and 2. So 100 minus 22, you get 78 is equals to 10,000 minus 2,500. I'll get 7,500A plus 100 minus 50B. I'll get 50B. C minus C inaisha. You can call it equation number 4. Then, or you can just do this minus this, but zote zitakuwa negative, still okay. Now, using equation 2 and equation 3 to eliminate C. So I'm using the second one and the third one. So I'll do 436 minus 100. So I'll get 336 is equals to 40,000 minus 10,000. Utabakia na 30,000 A. 200B minus 100B. Utabakia na 100B. C minus C inaisha. So you can call it equation number 5. Now, using equation 4 and equation 5. Now I'm using equation 4 and 5, Here na here. So like this one will be 78 is equals to 7,500A plus 50B. This one will be 336 is equals to 30,000 A plus 100B. So how do we substitute that? So I can eliminate B. Hii ni multiply by 2, hii ni multiply by 1. So itakuwa aje? So 2 times 78 itakuwa 156 is equals to 2 times 7,500, that one you get 15,000 A plus 2 times 50 you get 100 B. Hii ni times 1, Kwa hivyo inabakia 336 is equals to 30,000 A plus 100 B. Then we can minus. So 100 minus 100 hiyo inaenda, So 30 minus 15 itabakia 15,000 A is equals to 336 minus 15, 156, hiyo utapata 180. So that means A itakuwa ngapi? So give me A there, post your answer there. It's 180 is equals to 15,000 A. So give me A. I can see Isaac negative 83. Wachieni hapo. So now half of the class could have failed that question. Half of the class could have failed that question. If you have written 83, hiyo ni wrong. Hebu tuangalie hapa. It's 180 is equals to 15,000 A. That means you divide both sides by 15,000. So it's 180 divided by 50,000. 15,000. Not 15,000 divided by 180. Msione ikiwa rahisi venye mnafikiria. That's why I knew. That's why I have told you to compute that. Yeah. So it's 180 you divide by 15,000 A. So, and you get 0.012. 2. That's how we get A. Wacha kuandika answer saa hizi, because I already said it. So now, if you have A, now we can get our B. Now let's get our B, and also we can get even C. So this is what you do. So I can use equation 4 or 5 to get B. Like for example, you see if I use this equation, because I already have A, kwa hivyo itakuwa 30,000 times A, which is 0.012. Then pereka the other side, divide by 100B. Hiyo si itamuonyesha. Let me just give you an answer. Itakuwa negative 0.24. If you have A and now you have B, you can get C using either equation 1 or 2 or 3. Like if you use equation 1, you have 22 is equals to 2500 times A, we already have A, plus 50B, you already have B, we can get C. So I'll not take you back there. Now utapata C ni 4. Yeah, that's the fixed cost. So the two sitamuonyesha how to equate. Kama umefika QA, that means the other levels unajua. Good. So I think we are through with number 1 of the required. Yeah, number 1, they wanted the marginal cost function. Number 2, the total cost function. The total cost function, given that the fixed cost of production is 10, they want the total cost. Now that one will be easy. How do you get the total cost? So, number 2, to get the total cost, you integrate marginal cost. Actually, wacha tuandike, hatujaandika marginal cost. The question, they wanted the marginal cost. So the marginal cost will be, this was a equation, AQ squared. So you already have A. Our A is 0.012 Q squared. Plus BQ, we already have B. Our B ni minus. Kwa hivyo itakuwa minus 0.24 Q plus C. Na C yetu tumepata ni 4. Actually, that's the marginal. That's what they wanted. That's the marginal cost function. 0.012 Q squared, that's present A. Ndio hii tumepata A hapa. Plus BQ, our B is negative, that itakuwa negative 0.24 Q plus C. Our C ni 4. So now to get the total cost function, that's number 2. They want the total cost function. So you integrate marginal cost in respect of Q. So how do we integrate this? So it equals 0.012 Q squared minus 0.24 Q plus 4. So you add 1, 2 plus 1 is 3, then you divide by 3. So that means the total cost itakuwa 0.004 Q cubed minus the same as Q raised to power 1. 1 plus 1 you get 2, then you divide by 2. So utakupata 0.12 Q squared plus hii 4 is the same as Q raised to power 0. I mean Q raised to power 0. So 0 plus 1 you get 2 and you divide by 1. So utapata 4Q. And then plus the constant. Now the constant in this case, now this is the total, this is the variable cost, but then you add the fixed cost. We are told that the total cost function, given that the fixed production cost is 10, then you add 10. That is it, number 2. Let's go to number 3. Number 3, we are told that the number of units of component that should be produced and sold in order to maximize profit. In order to maximize profit. So ukisikia mambo ya ku maximize profit, how do we get profit? Profit is total revenue minus total cost. We already have the total cost. And how do we get total revenue? Is the price times the quantity. Let's get the total revenue. Now from the question, you already been given the profit function here. I mean the price. So which was 4.28 minus 0.005 Q. That's the price. You multiply by quantity to get the total revenue. and you'll get that the total revenue will be, it's 4.28Q minus 0.005Q squared. So now let's get the profit. You take the total revenue, which is 4.28Q minus 0.005Q squared minus the total cost. This is the total cost tumepata hapa, the total cost. So nitatoa brackets, so itakuwa you minus 0.004Q cubed plus 0.12Q squared minus 4Q minus 10 is equals to 0. I've opened the bracket directly. Now let's bring the right term together. Bring the right term together. So let me start with the cubed here. So itakuwa negative 0.004Q cubed. Then we have negative 0.05Q squared plus 0.12Q squared. So hiyo utapata ngapi? That one should be positive, Positive 0.115. Is that the case? Yeah, Q squared. Then we have 4.28Q minus 4Q. So you get positive 0.28Q minus 10 is equals to 0. So now that's the profit function, but they want maximize. To maximize, so you differentiate profit in respect of quantity. So itakuwa negative 0.012Q squared plus hiyo na multiply na hiyo itakuwa 0.23Q plus itabakia 0.28 is equals to 0. So to get Q, use the quadratic, minus B plus or minus square root of B squared minus 4AC over 2A. So minus B. So our B in this case, it's, you see this is A, this is B, this is C. So minus B, our B itakuwa negative 0.23 plus or minus square root of B squared. Kwa hivyo itakuwa 0.23 squared minus 4AC. Our A, it's negative 0.012 times C. Our C, it's 0.28. Out of it, you divide by 2A. Yetu ni ngapi? Negative 0.012. So tumesema if you compute that, you get to answer a positive and a negative. You take the positive one, of which you should get approximately 20 units. 20 units. So let me give you some assignments. I want you to go and try these questions. December 2017, question 2C. November 2018, question 2A. November 2015, question 2B. June 2013, question 1C. Yeah, those are the assignments I want you to go and try. So I can see we are on time. So now, let me add you some few minutes. I want us to look at a certain concept. Whenever you are given an equation, for instance, that one has already been scrapped from the syllabus, but it was revived again. that was way back 2017, walirudisha kwa syllabus, so it can also come. The presence of constraint. Whenever you have a constraint, there is a method we use. It's known as the language. Now we are looking with presence of constraint. That means, this is what we mean. Assuming now you are told that to maximize that profit, the item you require, the what we call the input variable, are restricted to a given value, So how do you adjust on that? So we use a method known as the language. The language method. Now, the language method is a method used to compute when there exists what we call a constraint. So, and what's a constraint? A constraint is a factor that can limit maximization. So in that case, how do we compute this? So, and this is how you show the language is denoted by that, by M. Yeah. So let's do an illustration there. I want us to try an illustration, then I give you a question there. So I want us to do this question, language. So solve the following function. You are told that to maximize Z or to maximize the profit, you are given the equation there, but you are told subject to. So if you are given subject to, that means there's a constraint. So we have some condition. So how do we solve on that? This is what you do. So you maximize that subject to. Now, like this subject to, x plus y is equals to 2. You see, if you're told that x plus y is equals to 2, is the same as writing this way. X plus y, you unapeleka the other side, minus 2 is equals to 0. So, ushike hiyo, that x plus y is equals to 2 is the same as writing x plus y minus 2 is equals to 0. So now, let me write that equation again. You are told that you need to maximize z, which is negative 2x squared minus 10y squared minus 8xy. I am rewriting it again here, plus 18x plus 34y. Then you're told subject to x plus y is equals to 2. So how do we solve that? This is how you solve. So you introduce the language. So utasema language, or your differentiating language, is equals to, you show that x, then you show what I mean L, x, y, and then you bring the lambda. You bring the lambda is equals to, so itakuwa minus 2x squared minus 10y squared. I'm just copy the way it is, minus 8xy plus 18x plus 34y. Then you add, you show that sign, then you show this. X plus y minus 2. Imeleta the other side, show it as one equation. I've now just combined the first one and the second one. Now, when you are adding the subject to, tunaweka this, the lambda, yeah, the lambda. So now how do we show that? Now from there, we need to differentiate. You differentiate language in respect of x, you differentiate language in respect of y, and then you differentiate language in respect of lambda. So itakuwaje? So tuanze na x, 2 times 2, kwa hivyo itakuwa negative 4x. We have another x here, so itakuwa minus 8y, because tumetoa x, is x raised by 1 times 8, inaenda unabakia na y. Then we have 18x. Yeah, this was 18x. Yeah, kwa hivyo itakuwa plus 18 is equals to 0. So you can call it equation number 1. In respect of y, hapo hakuna y, we have y here. So itakuwa 2 times negative 10, it will be negative 20y. Minus, we have another y here. We have another y here. So it will be 8x. If you substitute in respect of y, utabakia na 8. na x I mean. Then we have 34y plus 34 is equals to 0. You can call it equation number 2. Now if you differentiate in respect of lambda, itabakia tu venye iko. So utasema it's x plus y minus 2 is equals to 0. Itabakia the same. Now this is what I mean. Namaanisha, you see if you open the bracket here, itakuwa Lagrange x plus Lagrange y minus 2 lambda. So we differentiate in respect of that. You see itabakia x plus y minus 2. So if you differentiate in respect of Lagrange, hii huanga haichange, itabakia the same. Now from there, using equation 1 and equation 2 to eliminate lambda. So this one was supposed to, here hatukuwa tunaweka hii. Also here plus lambda, because if you differentiate this, you see hapa, here we had x. If you differentiate x, kwa hivyo utabakia na lambda, also hiyo utabakia na, if you differentiating in respect of y, you'll also remain with this. Utabakia na hii. So here you add that. Using equation 1 and 2 to eliminate lambda. So like this one itakuwa minus 4x plus 8y, you can call it plus lambda. 18 peleka the other side is equals to minus 18. Then equation 2 ndio hii, tuanze na x. So itakuwa minus 8x minus 20y, kuna kalabda hapo, plus lambda is equals to E34 peleka to the other side is equals to negative 34. Then I think you can minus or you can add. We are eliminating lambda. We minus. If you minus on that, what will you get? So itabakia 4x, itabakia 12y, itabakia 16. Remember you are doing minus 18, minus, inakuwa positive. Like this one itakuwa 8 minus that. Was it minus? This was negative. Yeah, this was minus. Sorry, this was negative. This was negative here. So it will be negative 8 minus 20 minus 4 minus 8. You get that. So you can call it equation number 4. Now with that, because you already have equation 4, you can use, now using equation 4 and 3. You see equation 3 was x plus y minus 2, hii peleka the other side, is equals to 2. And you have gotten equation 4 as 4x plus 12y is equals to 16. So kutoka hapo, we can eliminate x. You multiply by 4, you multiply by 1. So hii itakuwa 4x plus 4y is equals to 8. Hii itabakia 4x plus 12y is equals to 16. Then you minus. 16 minus 8, you get 8 is equals to 12 minus 4, you get 8y. So that means y is equals to 1. Now ukishapata y, you can get x and you can get lambda. X, you see now like x plus y is equals to 2 and y is 1. Kumaanisha x itakuwa also 1. Now to get lambda, you can use any of the equation, either equation 1, equation 2, or equation 3. Yeah, like this one. Like minus 4x minus 8y plus lambda is equals to negative 18. You substitute to get lambda. I'm not show you how to get that. Now utapata ni minus 6. So in respect to this, I want you to go and try this question. It was tested May 2018, question 2D. Then ukifanya, it's already there in the notes. So you do it and then you mark for yourself. So now let me give you like 3 minutes to ask live question. Live question, not text, in case you have a live question. Just raise your hand in case you have a question or a compliment. So ask the questions. A question or a compliment? I'm giving you 3 minutes before I disappear. Kuna Isa hapo. Isa. Isa hapo. Isa.
Yes.
You have raised your hand, Why are you laughing? Ask the question. Victor.
Yeah, so yeah.
Go on.
Yeah, it's on the quadratic equation.
Sorry?
Yeah, your quadratic equation.
Gani? Yeah, the first question, the second, the third, the fourth, the fifth, the sixth. We have done 7 questions,
Yeah, it is in May 2015.
May 2015.
It's in the last. Yeah, the portion.
Sorry?
How you calculate the Q.
How I calculated what?
The Q. It's this formula for B
the quadratic,
minus 4AC. Yeah, the quadratic.
Hiyo ndio umepotea. There is the question there. Seen that one, May 2015.
Yeah, lakini uko chini kabisa. Uko chini kabisa.
Huku?
Uko chini kabisa.
Si huku ni chini?
Hiyo quadratic. Enda kwa quadratic.
This is the quadratic.
As in ni 3.
Which place in specific?
How to get
this?
Ile tumepata 21.
Sorry?
21 units. Uko chini kwa 20.
Oh, how to get to your problem is all about using calculator there.
Yes.
So
yes.
Now if you have this equation, so this will represent A, B, and C. I know you know that, Your problem comes in here.
Yes.
Ni hapa ama ni hapa? 1 or 2?
Ni hapo. 2.
Hapa ama 2,
Yeah, 2.
Okay, so this is what you'll do, You take 4 times negative 0.012, and then you multiply by 0.28. You press equals. Then you take 0.23 squared minus answer equals. Then you get square root of the answer equals. Utakuwa umepata hiyo yote. Sawa, Then from there, it's either plus or minus with that, then you divide by the answer by that.
Yes. Okay, sir.
Disha Isa. Isa, go on.
Hello, teacher.
Yes.
Hello. Nauliza. Hello.
I can hear you.
Hello. Hii language. Inakuja. The language inakuja.
Yeah, itakuja.
Hey, tutarudia.
Hiyo soma the illustration. I have written the illustration.
Inafanya mpaka naogopa hizi zingine.
So kindly work smart. If you don't understand, achana nayo kabisa. Agnes.
Hello. So This unit is quite wide. I have actually sat for it twice.
Twice, eh?
And yeah, this time round I just have to pass.
So you have experience, eh?
So my question to you is, and actually as you're teaching, I am seeing areas of where I would have done better if I just came for your classes. But my question to you is, am I safe if I just concentrated on what you're teaching only?
So for what I usually do, eh? My students have to pass, eh?
Good.
So the topic I'm going to cover, actually number one, I'll accomplish the syllabus before July, if that's the time you'll do exam. But by the end, let's say the 2 weeks to exam, I'll have covered all the vital areas that I know will be tested. So kindly be safe. Yeah, I'll do all the topic that I know must be tested. You'll be safe.
Okay.
Yeah.
Okay.
So kindly, and then if you are reading my material, kindly don't use other material. Because what I've done with my material, I have given a summary. A summary, and then I've written something that students need to know. Sijakupea all the other my vitu zingine, you don't need to know them.
Thank you for clarification.
Okay, karibu. And then if I cry on something, for those who are doing QA, there was some student asking about the sharing of videos. So we have come into consideration. We are developing a system in which, for those students who had paid, they can be able to access them later, but not for now. For now, what we are doing have not yet developed that system, because now we are trying to avoid the circumstance where we share the video and then you distribute to others. You see, these are our copyright. I mean, these are our asset. Actually, this is my asset. Like you, this is my asset. If I try sharing, sending to you, then you send to your friend, then it's targeted to the market. Others will use for commercial purposes. So you're trying to avoid that. So what we are doing, we are coming up in a system where you as a student, you'll have to log in an app, and then you can, the only one who can access it. And then from that, we can give you a time period, like 1 month, 2 months, of which you have to view it through that period. After that period, we shall delete it from the system. That's what we are dealing with. So kindly bear with us. So for now, currently, we are not sharing the videos, but we are coming up with a system where all the students who have enrolled for this unit, they'll be able to access the videos later. So I think no one else is raising the hand. Charles, hauinui hapo, unainua hapo kwa system, si kuinua kwa screen. So kindly, so there is an icon there where you can raise a hand. I can see you are doing for
Hello.
me that. Yes, I can hear you.
My question was on May 2019. The question you gave us for assignment.
Yeah.
We have told
I can see there is a Q there. I know where their problem is. It's not about Q. Divide by Q,
it's break-even time interval.
No, that's last sitting. That's November 2019.
Yeah.
That's November. That one I not given as an assignment. I might tackle that one during the blocks.
Oh.
Yeah, but break even, kubuka at break even, demand is equal to supply. Nimekupea hint.
Oh.
Yeah.
Thank you. It was good session.
Okay, karibu. Paris, do you have a question? Yeah, Hannah. Doreen. Okay, sir. So have a good night.